So let's continue with graphing. We'll now look at what's called a quadratic function. A quadratic is a function that has an x squared somewhere in the equation. Okay, so this is an example of a quadratic. Let's grab our calculator here and graph this. 3 bracket x plus 1 squared minus 4. And we'll graph. Okay, now if by chance you don't see that graph, you're going to have to adjust your window, but typically if we go to a standard window, which is what it's usually set on, that's what's going to show up. Okay, so let's write a few things down here. First of all, our domain is negative infinity to infinity. Okay, if you look at the graph, you can see that it's going forever in both directions. Okay, the range we're going to have to figure out because we have to, this parabola has a lowest point. So we're going to have to figure out what that range is. Okay, to graph it, I need to know these three things. I need to know the Y-intercept, the X-intercept, and the vertex. So let's go back here, and we'll go to second trace. Let's figure out the Y-intercept first. That's where x is 0. And if I press that, it says y is negative 1. Okay, so I can plot a point here at negative 1. Then I'm going to go to second trace again, and I'm going to do the zeros. Okay, now here's the problem. Can you see there are two x-intercepts? And this is why we have to tell the graph where to look. So I'm going to set a left bound. I'm going to go way over to the left side of the left x-intercept. So go enter. And now be careful. I want to just go past the x-intercept, but not too far. Okay, so now I've decided to tell the calculator find this x-intercept. Okay, so the first one is negative 2.15. Okay, now what I want to do is do the same thing. So I'm going to go to trace 0, and now I'm going to set the left bound. Well, let's go somewhere around here, and the right bound on the right side of the second intercept. Okay, and this time it's 0.15. So you can see if I want to label this 0.155, and I'm going to label this one negative 2.15. Okay. Now we need the vertex. If I go to min or max, what do you think this graph has? A minimum or a maximum? Alright, if you think about a graph, it's either one of these two. This one has a minimum, and this one has a maximum. Okay, so if I go back here, I need to find the minimum. So I'm going to press 3. And again, I have to set the left bound and the right bound, because sometimes there will be more than one minimum or maximum. So I go to the lowest point there, and I want to put the cursor to the left of that lowest point, and then the right bound will just be to the right of that lowest point. And again, I don't need to guess, I want to know what it is. So the vertex says the x value is negative 1 and the y value is negative 4. Okay, so that looks like it's about here. And that's going to be good enough to graph this parabola. Alright, now once I have the max and the min, the minimum is y equals negative 4. This tells me about my range. My range is going to be from negative 4 up to infinity. Okay? And the end behavior, alright, this one is similar as x approaches infinity. So what's happening as x approaches infinity? You can see that we're going to rise to the right. The graph rises to the right. And number of turning points, there's 1. Okay, it changes direction at the vertex. Okay, so pause the video, see if you can do this next one. All right, here are the answers for this graph. A couple things I want to highlight. The end behavior, I put a couple different answers there. I said as x approaches infinity, y decreases. Or if you want to say as x approaches infinity, the graph falls to the right. Or if you want to say the graph moves from quadrant 2 to quadrant 4. As long as you get the impression that it's falling to the right, it's as the graph gets, what's happening in the far right. That's what we're looking for. Okay, so take a look at those answers, see if they make sense to you. If you didn't get one of those, please bring it up in class and we can discuss it. Okay, the number of turning points, there is one turning point. All right, going to cubic functions now, degree 3. So you can see the degree 3 because there is a cube function. Okay, so let's try graphing this one. We'll go to y equals and clear and put in x to the power 3 plus x squared minus 2x plus 4. By the way, there's another way you can put to the power of 3. If you go to math, you can see there's a little 3 there. You can do it that way as well. Okay? I just found that quicker to do it this way. All right, and we graph it, and we get this shape. That's a little bit different. Okay, so something like this. All right, what we're going to need to do is find the X-intercept, we're going to have to find the Y-intercept, and we're going to have to find this maximum and this minimum. It has both. Okay, so domain is easy. Range is easy because it goes in both directions forever. Let's do the Y-intercept. So we'll go second trace. 1. When is x 0? What does it enter? We get 4. Okay, so let's put that on the graph. Now let's do the X-intercept. Nice that there's only 1 this time. Okay, so we have to give it a left bound. Got to go to the left side. Now, oops, I went a little too far. It doesn't always, left doesn't always mean below. It means if you think about where the x-axis is and where the x-intercept is, the left bound has to be to the left of the graph. Or sorry, the left of the x-intercept. And now I want to be on the right side of the x-intercept, and you can see the boundary has framed where the x-intercept is. If your arrows don't look correct like that, it's not going to give you an x-intercept. Okay, so the x-intercept or 0 is negative 2.47. Okay, then relative max. So we're going to do the max first. So second trace. The maximum is 4, so go. Now you can see the maximum is sort of like where it peaks going up. Okay, so I'm going to set the bounds around that hump right there. And we can see that the max is 6.11. Okay, so I'm going to write negative 1.21. Oh, it should be 22, comma 6.11. Okay, now the max is 6.11, but I'm going to put it as a point. All right, and then I want to figure out what the minimum is. So second trace, minimum is 3. Okay, and I want to be to the left, and now I want to be to the right. And my minimum is at 0.55. 3.37. Okay, so I'm writing it as a point, but it would probably be more appropriate to say, sorry, the minimum is 3.37, and the max is 6.11. Okay, so let's label some of these points. Negative 2.47. This point is negative 1.22, 6.11. This point is 0.55, 3.37. I'm using 2 decimals every time. Unless it tells you something different, that's fine. Okay. Number of turning points. You can see this one turns twice. It turns to go down, and then it turns again to go up. So there are 2 turning points. Okay, pause the graph, and you can do this next one.